What's up guys, this is Professor Spawn. In this demo, we are going to see about what is exactly a linked hash map. In the last demo, we have seen about an hash map demo, right? So before we start with a linked hash map, I have created a class name called as a linked hash map inside a package called as map. And here I have created a class, and inside that I have created main method. So before we start with an hash map or linked hash map rather, so let's create a hash map first. So I'm going to create a hash map which is of type string comma integer, and I'm going to name this. So let's import this package from the util, and I'm going to create this, let's say, employee record. So I'm going to have an employee record here is equals to new hash map. Now let's put some employee records. So I'm going to put, let's say for example, I'm going to use the previous example. I'm going to put it for John as a salary of $1,500. I'll again create one more record for Henry, and here what I'm going to do is I'm going to put his salary as $2,000, and then I'm going to again create one more record, let's say for Johnny, and here I'm going to have a $3,000 salary, right? So let's try to print out this employee record. So let's run this code. So I'm going to run this code, and you'll notice the output as, the first one is Johnny. Even though we have inserted the first key value pair or the first table inside a dictionary as John and and his respective salary, but if you print out the hash map, the order of insertion is something different, right? So the first one is Johnny, and then we have John, and finally we have Henry, because the hash map doesn't care about the insertion order, right? So if you print out the hash map, the insertion order is random. But let's say that your manager comes and say to you that create a dictionary or create a table in such a way that I want to maintain the order of the insertion. So to do that, what you just need to actually change, even though this has a map interface, right? So this is a map which is an instance of an hash map. So you just need to really change it to linked hash map. So what linked hash map really does is whatever the insertion you have done, that it will maintain the same insertion order. So let's run this code and let's see what happens. So as I run this code, you will notice that the first insert I did is for John, the second is for Henry, and the third is for the Johnny. So basically, the linked hash map is actually maintaining the order of insertion. So this is why it is very important to know collections, right? It's like if you use, let's say, a wrong collection called as an hash map, then you would have to sort the keys, and then you could have a data structure in such a way that those will maintain the insertion. But here, insertion order is important, right? So let's go into the linked hash map class, and if you see here, right, so I'm going to go into the constructor. Rather, before going into the constructor, let's see about the class. So if you notice, the linked hash map actually extends the hash map class. So what does this mean is linked hash map is a child of hash map. Rather, linked hash map is an hash map. So as you know, as we have seen in the object oriented programming, inheritance follows and is a relationship. So here, linked hash map is a derived class from an hash map, and finally it implements the map interface, right? So every method inside an hash map is already present in a linked hash map, and internally linked hash map maintains doubly linked list to maintain the insertion order. So that's the difference between the hash map and a linked hash map. Both linked hash map and hash map are not synchronized, so both you know offer a similar performance. So let's go into the linked hash map constructor. So to do that, I'm going to go into the first constructor. It will have the same as initial capacity and load factor, right? So the default capacity is 16 and the default load factor is 0.75, which I think is optimal for most of the operation. And inside this constructor, it is actually calling the parent class constructor, right? Using a super keyword. We have seen that in an object oriented programming. But if you notice, there is one thing called as an access order, which is a Boolean instance variable of linked hash map. So we'll see that in a demo. What does that actually does? So there is a significance for this access order Boolean. Let's see the other constructor. It actually offers just an initial capacity. You can have an initial capacity and a load factor, or you can have a linked hash map with an initial capacity. Also, then there is a default constructor which calls the super constructor, right? So every constructor of linked hash map calls the super constructor. And then we have an access order of false. Also, there is one more constructor which can accept a map instance again, right? And then you can basically like having adding a map, already existing map, into this linked hash map. And then let's see, there's one more constructor, and this is the interesting constructor because it accepts the third parameter, which is called as an access order, right? So if the access order is true, it maintains, the ordering mode is access order. If the access order is false, which is by default it's false, it's the ordering mode is an insertion order. So we'll see that using when we actually do a linked hash map demo. So this is a very interesting constructor, and let's go into the demo. If you notice this access order, it's by default false, right? So it's not initialized here. So by default, it is false. So let's see here, I have created a linked hash map with a default constructor here. I have put in all the records here, and I've printed out, and it actually maintains the insertion order. Let's say, for example, I'm actually giving the initial capacity of 16 and a load factor of 0.5f, which is by default, right? And let me format this up. So I'm actually providing a 0.75f, and let's say the access order is true, right? So what I here did is the access order, I am actually setting it to true. Now, let's run this code. So when I run this code, so it has the same order of insertion, but let's say that I access a record for, let's say, John. So I'm actually accessing the value for John, and let's now try to print out the linked hash map. So when I run this code, right? So when I run this code, you see that the order is now changed, right? So when I first printed out the linked hash map, the order remains the same. But as soon as I access some value of John, the order literally changed, right? So the first one is Henry, then we have a Johnny, and then we have a John. Why John has been shifted at the end of the linked hash map? So because of this access order is set as true, this linked hash map is actually acting as a least recent, it's basically called as LRU cache. So in LRU cache, if you access elements, let's say you have 3 records here, and if I access John, this will be pushed to the end of the map, or rather a dictionary, because the least used record will be pushed to the first, right? So if you notice, I've accessed the John, so Henry will become first, John will become the second, and this John will actually be at the last because this has been accessed. And this is acting as an LRU cache, so and as I access the John record, so John will be pushed at the end. So let's try to do some more operations. So what I'm going to do is I'm going to have an employee record dot get, let's say, Henry, and let's see what happens to the order. So let's run this code, and you'll notice the output, the ordering becomes changed, right? So now the recently used record is Henry, so Henry has been pushed back at the end. The John is at the second last, and Johnny is at the first because it hasn't been used, right? So the least used record, or the least access record, will be pushed towards the towards the first, like towards the 0th index. So let's record, let's do some more operations. So I'm going to do an Henry, I'm going to access the record for Henry 2 times, and let's say I access for John 2 times, and let's try to access the record for Johnny, you know, 1 time. So let's say 2 times, right? So I'm going to do an S out again, employee record dot get Johnny here, and let's see what is the order of the data inside a linked hash map. So what I did here is I accessed the record for Henry, which is 3 times. I accessed the record for Johnny 2 times and for John 2 times, right? So if you notice, the Henry's record, comes at the first, then we have John, and then we have Johnny at the end, right? So here basically, the order has been changed. So let's try to do some more example. So let's remove this one more Henry. Now the access order has been changed. So both are equal. Both have been accessed equally. But now if you notice, the Henry is at the first, then we have John, and then we have a Johnny, right? So as Johnny has been accessed, the recent, right? So it has been pushed at the back. Then we have John, because after Johnny, the John was accessed, and then the Henry was accessed, right? So look from bottom to top. So the first one access will be at the end of the linked hash map, and after Johnny there is a John's entry, so John will be at the second, and then we have Henry. Let's say for example, I'm going to again copy this, and I'm going to paste it here. So the recently accessed record is Henry. Let's run this code, and you'll notice this actually the table changes. So Henry is at, you know if you look from the bottom to the top, so Henry will be at the end, which is very much true. Then we have Johnny here, and then we have a John, right? So this is how it actually works. So this is all about Hashmap. Linked Hashmap is very much similar to Hashmap. It's just that you can actually maintain the insertion order, and you can convert the linked Hashmap to an LRU cache with this Boolean flag called as access order. So if you uh, uh, change this access order to false, this will be a normal linked hash map. So the order will be maintained. So if you see that the initial linked hash map as well as the final linked hash map remains the same. So this is about that constructor, the interesting constructor we had in linked hash map. So this is all about the linked hash map. In the next demo, I'm going to come up with a tree map, which is also a kind of a map dictionary, a map data structure, or a hash table. Till then, goodbye and see you in next tutorial.